Hello everyone. Today we're going to look at how to solve quadratic equations by factoring. First of all, when you are asked to find the zeros of a quadratic function, the zeros represent the x-intercepts of the function, which are also called the roots. X-intercepts are called zeros because they represent the x values when the y is equal to 0. So that's why we call those x-intercepts as the zeros of the function. Now here we have the quadratic equation x squared plus x minus 2. If I asked you to find the zeros of the quadratic function using the graph, you would look for when the quadratic touches the x-axis, which occurs here at x is equal to -2 and 1. Now if you didn't have the graph, you would still be able to solve for these zeros by factoring. Factoring is a topic that is covered in Algebra 1, but we're going to be reviewing all of factoring today. As a reminder, when you're factoring is to undistribute. So let's say if you had x plus 3, x minus 1, that would be a factored form of the quadratic equation. And then when you multiply everything out, that's when you get an equation in standard form, such as this one, the x squared plus x minus 2. So now, when we're trying to factor, we already know because this is x squared, we're going to open two parentheses, and we would make one x here and x. And then we have to think of the two numbers that multiply to give you the last, which is -2, and add to give you the middle, which is 1. So remember, it's just the numbers. Two numbers that multiply to give you -2 would be 2 and -1. And if you were to add them together, you would get a +1, which gives you that middle term. If you ever get confused, let's say if you used -2 and 1, which do multiply to give you -2, then -2 plus 1 gives you a -1, so it can't be that. So you kind of have to play around with your numbers until you figure out the correct ones. So this is a +2, so we would put x plus 2, and a -1, so we would put x minus 1. And since we're trying to figure out the x values when y is equal to 0, we make this equation equal to 0. And then to solve for the x-intercepts, we would set each individual factor, so x plus 2 equal to 0 and x minus 1 equals to 0. This is called the zero product property, which we're going to review later on in this lesson as well. But basically what it says is if one factor is equal to 0, then it doesn't matter what this one is, the entire equation would equal to 0 because anything times 0 is 0. So that's why we set each individual one equal to 0. And now we go ahead and solve for each one. So for x plus 2, I'd have to subtract the 2 to both sides. So x is equal to -2. And for the x minus 1, we would add 1 to both sides. So x is equal to +1. And we can see that we would get the same answer as when we did by looking at the graph. Let's go ahead and practice factoring a little bit more because I know that this is where we tend to have some difficulty. So for this first one, we have x squared plus 9x plus 20. So again, I'm going to open my two parentheses. I'm going to put x here and x. And now we have to figure out what two numbers multiply to give you 20 and add to give you 9. If it's helpful, you can also create like a list on the side of all of the possible factors of 20. So for example, you could say 2 and 10, as well as -2 and -10, because -2 times -10 is a +20. We have 4 and 5, and -4 and 5, as well as 1 and 20, and -1, -20. So you don't have to go through this, but this is just in case if you get stuck and you can't figure out what the correct pairing would be. From here, you can look at it and say, okay, so these are all numbers that multiply to give me the +20, but now we have to figure out which one of these adds up to give me a +9. 2 plus 10 is 12, so it's not this one. -2 minus 10 is negative 12, so not that one. 4 plus 5 is 9, so it will be the 4 and 5. So that's a positive 4 and a positive 5. So my factors would be x plus 4, x plus 5. Moving on to x squared plus 14x minus 72. So we can create our two parentheses here, x and x, and I can start making a list of numbers that multiply to give me 72. We have negative 72. We can do negative 8 and positive 9, but negative 8 plus 9 is a positive 1 and not 14, so it can't be that one. We could do 9 and negative 8, but 9 minus 8 is 1, which can't be that one either. We can try 18 and negative 4. 18 times negative 4 is negative 72, and 18 minus 4 also gives me positive 14. So this would be my correct parent. So it would be x plus 18, x minus 4. For x squared minus 11x plus 30, we would open our two parentheses, x and x. Two numbers that multiply to give me 30 are 6 and 5. But if I add 6 and 5, it gives me a positive 11. So we're close. That just means that it would have to be negative 6 and negative 5, because this would still multiply to give me a positive 30, but add to give me that negative 11. So my factors would be x minus 6 and x minus 5. Now, if we look at this last one here, we have negative x squared plus 13x minus 12. In order to be able to write out factors like this, we can't have anything in front of the x squared. And in this case, what's different about this one is that we have a negative. So what we would have to do first is to factor out a negative. And again, when we're factoring, that is undistributing. So this means that a negative 1 was distributed to every term. So when I factor it out, I'm going to write a negative on the outside. And then I'm going to rewrite this quadratic with all of my signs switched, which would be a positive x squared minus 13x plus 12. And think about it. If you're ever unsure if you factored correctly, think of if you were to distribute this negative, you would get negative x squared plus 13x minus 12. And if it gives you what you originally had, then you're okay. So now that we have factored out this negative, we can now continue factoring what's inside of that parentheses. So we still have this negative on the outside, but now I'm going to open up my two parentheses. And I have to think of the two numbers that would multiply to give me a positive 12 and add to give me negative 13. So since this is positive and this is negative, that means that both of the numbers that were multiplied must have been negative. So that way when you add them, you get this negative answer. And when you multiply them, you get the positive 12. Two numbers that multiply to give me 12 are negative 4 and negative 3. But negative 4 and negative 3 give me negative 7, so it's not that. However, to get positive 12, we can also multiply negative 12 and negative 1, which would multiply to give me negative 13. So we would say negative on the outside, x minus 12, x minus 1. And this would be my completely factored form of that quadratic. Now, just like what we did with the negative, how I factored that out first, you'll see that all of these quadratics have something written in front of the x squared. So what we can do in these cases is factor out whatever we can if every term has that greatest common factor. So to factor out a greatest common factor means to divide out what each term has in common. Basically, you will look for something that everything has. So, for example, 6x squared plus 9x. Both of the numbers, so I look at my numbers first, both of the numbers are divisible by 3. So I could factor out a 3. Additionally, x squared and x, if I were to think of what both of them have, they both have an x. So I can factor out an x as well. And so what I'm doing here is I am dividing 3x from every term. 6 divided by 3 is 2. And if I took out an x and there were originally 2, that means that I have 1 left. Plus 9 divided by 3 is 3. And since I already took out the x, I don't have an x anymore to write inside. So this would be my factored form of that particular quadratic. If we could keep factoring, we would. But if there are no more exponents, then we can't keep factoring. And again, if you're unsure of how this works, think about if you were to distribute that 3x again. If you were to distribute 3x times 2x is the 6x squared, plus 3x times 3, which is 9x. And that gives me my original function. So we know that this is correct. Let's look at B. We have 4x squared plus 20x minus 56. If I look at every single term, every single number here is divisible by 4. So I can factor out a 4. Additionally, I'm going to look to see if every term has at least an x, and they don't, so I cannot factor an x. So that means I'm just taking out a 4, and I would divide every single term here by 4. So 4x squared divided by 4 is x squared, plus 20x divided by 4 is 5x, minus 56 divided by 4 is 14. And now we do the same thing we did before. I can keep factoring this quadratic that is inside of the parentheses. So we would write that 4 that we had on the outside, and now I'm going to open up my two parentheses. Two numbers that multiply to give me negative 14 and add to give me a positive 5 would be a positive 7 and a negative 2. 7 times negative 2 is negative 14, and 7 minus 2 is a positive 5. So we're good here. So this would be my completely factored form of that quadratic. 7x squared minus 21. If we look here, the only thing that both of these terms have in common is that they are both divisible by 7. So if I take out the 7, that means that 7 divided by 7 is just the x squared, minus 21 divided by 7, which is 3. And again, if I could keep factoring, I would, but this is x squared minus 3. We don't have that middle term, and it's not a special case that we'll discuss at a later lesson. So this would be my factored form of that quadratic. Moving along to D, we have negative 9x squared minus 9x plus 18. Every single term is divisible by 9. And additionally, we don't want to have a negative in front of the x squared, so we're going to factor out a negative 9. And since not all terms have an x, because this 18 doesn't have an x, I cannot factor out an x. So the only thing that can be factored is the negative 9. And now I'm going to divide negative 9 from each term. Negative 9x squared divided by negative 9 is just x squared. Negative 9x divided by negative 9 will be a positive 1x. And a positive 18 divided by negative 9 is a negative 2. And again, this is another quadratic, so we can definitely keep factoring. We have negative 9 on the outside. I'm going to open two parentheses. And now we have to think of what two numbers multiply to give me negative 2 and add to give me a positive 1. And the only two numbers that multiply to give me negative 2 are either negative 2 and 1 or positive 2 and negative 1. And the one that would add up to give me a positive 1 is this one. So we would write negative 9, x plus 2, x minus 1. And this is my factored form of that quadratic. Now let's look at if we cannot factor out a greatest common factor. So like for example, in this one, if you notice, we have 2x squared plus 11x plus 12. And if I want to be able to factor in the way that we were familiar with now, we would have to divide 2 from every term so that the x squared would be alone. But we notice that 11 is not divisible by 2. So therefore, we have to do something else. So this is a special case. We use what's called the AC method. And the only time I need to use this is if you have a number in front of the x squared that cannot be divided from every single term. So remember that your numbers here, the 2 is A, the 11 is B, and the 12 is C. So these are some steps here that we're going to follow. First, we're going to figure out what is AC. Now what that means is that I'm going to take A and C and multiply them together. So 2 times 12 is 24. And now what I want to do is I want to rewrite B. So just like before, how we were looking at what two numbers multiply to give you the last and add to give you the middle, what we're doing here is what two numbers multiply to give you AC and add to give you the middle. So two numbers that multiply to give you a positive 24 and add to give you 11 would be 8 and 3. What we do with these numbers now is that we're going to write the original expression, but we're going to rewrite this term, the middle term, bx, using these two numbers. So for example, this is what it's going to look like. We have 2x squared. That's from my original equation. Instead of writing plus 11x, I'm going to split it into 8 and 3. So I would write plus 8x plus 3x, because 8x plus 3x is 11x, plus 12. And now you're going to factor by grouping. Factoring by grouping is simply when you group these two terms together and these two terms together. And the order in which you write your b, like if you wrote 3x plus 8x, does not matter. You would still end up with the same answer at the very end. Your work in the middle may look different, but the final would still be the same. So now, just like we did earlier, we're going to look at these two terms only, and we're going to see what is the greatest common factor for these two terms. 2x squared and 8x are both divisible by 2, and they both have at least one x in common. So when I factor out a 2x, I have one x left because I took one out, plus 4. And since I already took out the x, I don't need to write x here. Now here, both of these two terms have a positive 3 in common because every term can be divided by a positive 3. The 12 doesn't have an x, so I cannot factor an x. So what I would do now is 3x divided by 3 is x, plus 12 divided by 3 is 4. If you factor by grouping correctly, these two terms here in the parentheses should be exactly the same. So now to write out your final factors, the one that is repeated is going to get factored out. Or basically what you can just remember is that will be one of your factors, the x plus 4. And then what's left, the 2x plus 3, that is your second factor. And now we have completely factored the quadratic equation. Let's have a look at a couple more examples. Here we have 2x squared minus 7x plus 6. Again, the 2 in front of the x squared is the problems. And if I could divide it from every term and factor it out, I would. But 7 is not divisible by 2. So therefore, this is an example of where I would have to use the AC method. Remembering that A is the 2 and C is 6. So we would do 2 times 6, which is 12. And now we have to think of the two numbers that would multiply to give me 12 and add to give me negative 7. Since the 12 is positive and the 7 is negative, that means both of my numbers that multiply to give me 12 have to be negative. So two numbers that multiply to give me 12 and add to give me negative 7 would be negative 4 and negative 3. And now I'm going to rewrite this quadratic using those two numbers for b. So instead of negative 7x, I would write negative 4x minus 3x plus 6. And now I would factor by grouping. Here I have every term in these two have 2 in common. You can divide a 2 out, as well as they both at least have an x. So when I factor out a 2x, I would be left with x minus 2. Now here we have negative 3x plus 6. Now whatever sign is in front of that number, that's the sign that we're going to use. So we're going to factor out a negative 3 since they both are divisible by 3. Now since I factored out a negative 3, that means negative 3x divided by negative 3 is a positive x, and 6 divided by negative 3 is a negative 2. Remembering that we want to have these two in parentheses the same, so that's why we factored out the negative, because originally that term could have been positive if we just factored out a 3. So now my factors would be the one that repeats, so x minus 2, and then what's left over, the 2x minus 3. Let's try that one more time. We have 4x squared minus 4x minus 3. Again, if I could divide everything by 4, I would, but the 3 is not divisible by 4. So again, I have to use the AC method. 4 times negative 3 is negative 12. And two numbers that multiply to give me negative 12 and add to give me negative 4 would be negative 6 and positive 2. So now I'm going to rewrite this quadratic using these two numbers. 4x squared minus 6x plus 2x minus 3. And now we factor by grouping. 4x squared minus 6x both are divisible by 2, and they both have an x in common. And when I divide 2x from every term, I would have 2x minus 3. Now, if you look at your second grouping, you have 2x minus 3. They have nothing in common. So if you have nothing in common, you can just say that you're factoring out a 1. So we would put plus 1, and then in my parentheses would just be the 2x minus 3. So we do that because the 2x minus 3 is already what's in parentheses. So again, if you don't have anything that you can factor, just use positive 1. So now for our factors, the 2x minus 3 repeats. That is what they have in common. So that's one of my factors. And what's left over, the 2x plus 1, would be my second factor. And this is my factor form for that particular quadratic. Now remember I mentioned that I would bring up the zero product property. So again, the zero product property states that anything that is multiplied by 0 is equal to 0. So we're going to apply this at the end, but first we're going to need to factor. Now before you can factor any quadratic, the quadratic must first equal to 0. That means that whatever I have here on the right side of my equation, I'm going to have to move over to the left. Or if you wanted to move what's on the left over to the right, that's fine as well. I usually just like to keep my x squared term positive, so I'm going to move these two terms from the right over to the left, meaning I'm going to subtract 14 and subtract this x. So that way this whole side is equal to 0. And we have x squared plus 5x minus 14 is equal to 0. And now we factor. Since we have nothing in front of the x squared, this means that we can factor like normal. We don't have to use the AC method. So I can write x, and the two numbers that multiply to give me negative 14 and add to give me a positive 5 would be a positive 7 and negative 2. So remembering, if one factor is equal to 0, then the whole equation is going to equal to 0. So once you have your factors set up, we basically take each individual factor and make it equal to 0. And then we solve for x. So here we'd have to subtract the 7. So x is equal to negative 7. And here we would add the 2. So x is also equal to 2. And these would be my two solutions. So now let's practice with a few more questions. We're going to find the solutions of all of these quadratic equations by factoring. We have in this first one, 2x squared minus 4x is equal to 0. Now, because this particular quadratic does not have a third term at the end, like that constant, the number without the variable, we're just going to look at what both of these terms have in common and factor it out. 2x squared minus 4x, both of these terms can be divided by 2, and they both have at least one x. So when I factor out a 2x, I would have left x minus 2 left over, and this equals to 0. So now these are my factors. I can't keep factoring anymore. So we would take each individual one, so 2x, and make it equal to 0, and x minus 2, make it equal to 0. If you divide 2, 0 divided by anything is still 0, which is a possible answer. And then I would have to add 2 for the second factor, so x is also equal to positive 2. And these would be my two solutions. For b, we have negative 10x plus 12 is equal to 2x squared. So we want to first make this equation equal to 0. We can either move every term to the right or move the 2x squared to the left. It does not matter, but I like to keep my x squared positive. So I'm going to go ahead and add the 10x over and then subtract the 12. So my quadratic equation is as follows. 2x squared plus 10x minus 12 is equal to 0. If I look at every term is divisible by 2. So I can factor out a 2. And I would have x squared plus 5x minus 6 is equal to 0. The two numbers, now that I factored out the 2, we have a regular quadratic equation that we can factor like normal. So I put x, and the two numbers that multiply to give me a negative 6 and add to give me a positive 5 would be a positive 6 and a negative 1. 6 times negative 1 is negative 6, and 6 minus 1 is positive 5, so that works. Now, this is important. If one of my factors, because technically we have three factors here. We have 2, the x plus 6, and the x minus 1. Remembering that we're only solving for x. I have only 2 x's here, so I'm only going to have 2 solutions. This 2, and I say this because I see this every year as a common mistake, this 2 is not going to affect any of my answers since there's no x attached to it. See, here there was an x attached, so that's why I set it equal to 0 to solve. But since this does not have any x's, I cannot set it equal to 0 and solve because there's nothing to solve. So the 2 does nothing for my answer. The only thing I have to worry about are these two terms here. So we would make x plus 6 equal to 0 and x minus 1 equals to 0. For this term, I would subtract the 6, so x is equal to negative 6. And for this one, I would add the 1, so x is also equal to positive 1. And those would be my two solutions. For this last one here, this is not a quadratic because you can see that we have the 3x to the third. However, we can probably see if we can factor this anyway. So let's see what happens. We're going to move everything over to the left side of the equation so that it is equal to 0. So I'm going to subtract this 24x, and we will get 3x to the third minus 6x squared minus 24x is equal to 0. Now we're going to see what does every single term have in common. As you can see, every single number is divisible by 3, and every single term has at least one x. So I'm going to factor out a 3x. And now 3x to the third divided by 3x would be x squared, minus 6x squared divided by 3x would give me 2x. And finally, negative 24x divided by 3x is a negative 8. So by factoring out this 3x, now we have a quadratic, and we can solve this. So we have 3x, and since there's no number left in front of the x squared, we can open our two parentheses to keep factoring. Put x, and the two numbers that multiply to give me negative 8 and add to give me a negative 2 would be negative 4 and positive 2. Now here, notice that in my final answer, I have 1, 2, 3 x's in my factors. That means that instead of only 2 answers, we're going to have 3. So we set each individual factor, so 3x equals 0, x minus 4 equals 0, and x plus 2 is equal to 0. For this factor, I would have to divide by 3, and 0 divided by anything is 0. For x minus 4, I would add the 4, so x is also equal to 4. And for this last one, if I subtract the 2, x also equals to negative 2. And these would be my answers. Last one here, we have 6x squared minus 2x minus 4 is equal to negative x minus 2. So again, we have to set this equal to 0 first. So we're going to add the x and add the 2. And we get 6x squared minus x minus 2 is equal to 0. Now, if you notice here, we have a 6 in front of the x squared. And if I can factor out a 6 from every single term, I would, but negative 1 and negative 2 cannot be divided by 6. So this is another example of when we would have to use the AC method. So we would do A times C, 6 times negative 2 is negative 12. And therefore B, the two numbers that multiply to give me negative 12 and add to give me this negative 1 would be negative 4 and positive 3. So now I'm going to rewrite this quadratic, replacing that negative x with the negative 4 and 3. So 6x squared minus 4x plus 3x minus 2 is equal to 0. Now we factor by grouping. 6x squared minus 4x. Both of these terms are divisible by 2, and they both have at least one x. So if I divide 2x from each of these terms, we would have 3x minus 2 left. If you notice in the second two terms, we have 3x minus 2. There's nothing in common, so that's where we would write plus 1. and we would just copy down that 3x minus 2. And again, if you notice, right, once you figured out this parentheses and you saw that 3x minus 2 here as well, automatically we're like, okay, the plus 1. So now my factors, the one that repeats, that's one of them, 3x minus 2. And what's left over is my second factor, the 2x plus 1, which is equal to 0. And now we're going to set each individual one of these factors equal to 0 and solve. So I'm just going to do that up here. We have 3x minus 2 equals 0. I'd have to add the 2. So we have 3x is equal to 2, and then divide the 3. So x is equal to 2 over 3 is one of my answers. And it's okay to have a fraction and just leave it as a fraction. For the other factor, we have 2x plus 1 is equal to 0. I would subtract the 1 first and get 2x is equal to negative 1, and then divide the 2. So my other answer would be x is equal to negative 1 over 2. And that's it. That's how to solve quadratic equations by factoring.